Hello, ladies and gentlemen. Welcome back to Math 20-2, Chapter 5, Lesson 4, Part 4, Normal Distribution. Now, last couple of questions before I set you off to your classwork. Is the data in each set normally distributed? Explain. Now, interval and frequency. So I'm not telling you what's going on, I'm just throwing numbers at you. Now, we can graph this. Actually, that's the easiest way to do it. We're not going to bother with the graphing calculator. So we're going to do frequency. And interval. So the interval is 10 to 19. The average there is what? Well, 10, 20, 30, 40, 50, 60, 70. And the frequency, the highest is 20. 5, 10, 15, 20. So just something crude like this. So here we got 3. Sorry, there we go. So that's 3. The next one is 5. 30 to 39 is 17, which is roughly 15, 17. 40 to 49 is 20. 50 to 59 is 11, 10, 11, something like that. 60 to 69 is 4. Now, the question was, well, first you draw a crude histogram, then you go, is that a normal distribution curve? I'm going, it goes up, it goes down. I'll go yes. Is it a perfect normal distribution curve? No. It's not quite symmetrical, but it's definitely bell-shaped. And you can see the left half looks an awful lot like the right half, and I'm putting the average somewhere in the low 40s. Like around 40. Is it perfect? No, but it's something like 20, 40, 50, 60 data points. So it's not that many data points. If there was a couple hundred, or a couple thousand, I suspect this would really look like a bell curve. Okay? Now, this next set of data, the interval, 2 to 5, 6 to 9, 10 to 13, 14 to 17, 18 to 21, 22 to 25, 2, 8, 8, 3, 4, 5. I'm going to say no right off the bat because this is going up, this is going down, and it's going up again. So it's going to go up. So no, that's not a standard normal distribution curve. Not a bell shape. Okay? Now, if you want to do a histogram for that, go for it. I'm not going to bother because I'm lazy. I mean, economical with my energy. Now, the key idea is here. Graphing a set of group data can help you determine whether the shape of the frequency polygon can be approximated by a normal curve. So do you have a frequency polygon? Yeah. Does it look like a normal curve? Is it approximating a normal curve? Yes or no. Now, you can make reasonable estimates about data that approximate a normal distribution because data that is normally distributed has special characteristics. Now, normal curves can vary in 2 main ways. The mean determines the location of the center of the curve on the horizontal axis, and the standard deviation determines the width and height of the curve. So the larger the standard deviation, the wider it is. Now, what you need to know, the properties of normal distribution can be summarized as follows. The graph is symmetrical. The mean, median, and mode are equal or close and fall at the line of symmetry. Notice I said or close. The normal curve is shaped like a bell, peaked in the middle, sloping down towards the sides and approaching zero at the extremes. About 68% of the data is within 1 standard deviation of the mean. About 95% of the data is within 2 standard deviations of the mean. About 99.7% of the data is within 3 standard deviations of the mean. The area under the curve can be considered as 1 unit since it represents 100% of the data. All right. Now, that's it for me on normal distribution curve. If you've got a question, hang on. Oh, sorry, one more bit. My apologies. Generally, notice I say generally, measurements of living things such as mass, height, and length have a normal distribution, like the height of the skiers or students' heights. Anyway. Now, if you've got any questions, shoot me an email. Otherwise, good luck and go do the classwork.